Hello, this is the course of data mining and applications. And in this slide, I would like to discuss about data warehouse. So the discussion on this slide will be about the basic concept of data warehouse and data warehouse modeling, which is about data cube and OLAP. What is OLAP? Okay, OLAP is the online analytical processing. And we will learn also the OLTP, online transaction processing. And in the data warehouse, usually we call it this as the online analytical processing. And the transaction DB, usually we call it as the online transaction processing. We have the data warehouse design and usage, the data warehouse implementation. So the implementation is the example from the existing works, and we are going to make the summary of this slide. So what is data warehouse? In the data warehouse, it defined in many different ways, but not rigorously. It means, it is a kind of decision support database that is maintained separately from the organization operational database. So we have decision support database and we have operational database. It is separated. Okay? It should be different. And the data warehouse, it will be a support for information processing by providing a solid platform or consolidated historical data for the analysis. Okay. Based on one of the experts in this domain, he is Inmon. Okay. He called that data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management decision-making process. So the data warehousing, it means the process of constructing and using data warehouses. So the characteristic of data warehouse, it is subject-oriented, integrated, time-variant, and non-volatile. So the data warehouse, it is subject-oriented. What does it mean? It means that it is organized around the major subject. Let's say if it is the customer, then you will include the customer data. If it is about the product, then you will include the product data. If it is about the sales, you will include the sales data. So it is based on the subject. And it is different with the operational, because in the operational, you will do the operational like the order processing or the consumer loans or account receivable, consumer billing, claims processing, saving accounts. So the data warehouse focusing on the modeling and analysis. Okay, modeling and analysis of data for decision makers. Not on the daily operation or transaction processing. The daily operation, so it means daily data or transaction processing. It is about the data for the transaction. Yeah. It provides simple and concise view around particular subject issues by excluding data that are not useful. Okay. Exclude means not include. Okay. Include is not including the data that are not useful. So if it is not important, we will remove it. If it is not in the domain, we will remove it. Especially the data which is not useful for decision support, it will be removed. It will be excluded. Okay? It will be removed or excluded if the data are not useful. The data warehouse is integrated. So the integrated means we want to construct by the integrating multiple heterogeneous data sources. The database, it is a relational database, but sometimes we can rely on files, flat files. Flat files means like text file, okay? Or maybe a CSV file, or maybe a document file, okay, or the HWP file. See, there's flat file, and there might be online transaction records. So online transaction record is in the web or it is in the cloud. In order to integrate, we may need the data cleaning and data integration techniques. So you already learned from the previous section about the data cleaning and data integration. So we need to ensure the consistency in naming, encoding structures, attribute measures, and etc. among different data sources. So for example, if it is about the hotel price, so we need to understand about the currency, because the hotel in Korea, if you are dealing with the hotel in Korea or you want to visit hotel in Japan, okay, so the price will be different and there will be a currency. The tax also will be different. Okay, some of the tax, if it is hotel, then it is high tax. But if it is a motel, maybe it has some low tax. Or if it is a residence, then maybe the tax will be lower. Okay. Breakfast cover. Yeah. So that kind of things will be counted for the data warehouse. When the data move to the warehouse, it is converted. So sometimes it can be 1 0. If breakfast cover, okay, 1. If breakfast not cover, then 0. Yeah, we can use that one. So in the data warehouse, usually it is a combination. Maybe it is an integration between the CRM, ERP, and other data sources. And once you enter the data warehouse, it will go to any decision support system like the dashboard or the budgeting or the reporting. The data warehouse is also a time variant. The time variant means the time horizon. Okay? The time horizon for the data warehouse is significantly longer than that of the operational system. The operational, what is operational? Operational database has the current value data. So the time horizon is 60 until 90 days. We call this is operational. And the records is up to date. It is to update records daily or maybe weekly or maybe bi-weekly. The key structure may or may not contain an element of time. However, the data warehouse, it provides information from historical perspective. So if you already have a lot of data, you may not want to use this database because there are so many data in the operational. So you need to move toward the data warehouse and the time horizon will be longer, maybe 5 until 10 years. So you need to distinguish between these two. This sophisticated snapshot of data and key structure contain an element of time. So every key structure in data warehouse, it contains element of time explicitly or implicitly. Yeah, because if it is already 5 until 10 years, of course we need to know when had it happened. But the key of operational data may or may not contain time element. The time element may be about the time is the transactional, when the transaction happened. Okay, so it can have the time element. And usually the data warehouse data contain like this time. Okay, this time we call this is the key. Okay. Yeah, the key to represent the time, and this is the data. It will be easier for the analyst to design the decision support. And the data warehouse is non-volatile. It means that it is physically separate store of data transformed from the operational environment. So we have this database OLTP. You still remember what is OLTP? It is online transactional processing. Online transactional processing. Okay, we call this is online. This one. It is for the transactional data or it is for the operational data, but it should be separated with the data warehouse. Operational update of data does not occur in the data warehouse. So for example, if you do in this OLTP, let's say today customer A purchase milk. Okay. And then maybe today morning. Okay. In the afternoon, the customer A come back to the store and return the milk because the milk has some problems. Maybe it means in the transactional data you may have a lot of update. If you have a lot of update data, it means the data is not stable. The data is not stable or unstable. So we need to put the stable data maybe after 90 days into the data warehouse. So the data warehouse environment does not require transaction processing. So you don't need to have any updates. So you don't need to have any modification. And recovery. Okay. The recovery, usually when you have this OLTP database, the people may have the interfere on the security. Okay, people do not want to hack the data warehouse. They want to hack the transactional database. So that's why in the transactional database, usually they have a recovery. If something happened, then it should be recovery. And concurrency control. So it should be real time. But the data warehouse, not. Okay? The data warehouse, you don't need to have the concurrency. And it requires only two operations. So the initial loading of data and access of data. So initial loading, so it means you will just read the data. After you read, maybe you need to get more data. Okay, just read another data, then finish. But for the transactional, you need to add, you need to change, sometimes you need to delete it. So we need to avoid this kind of operation in the data warehouse because now, we need to consider the OLTP with this kind of operation, and it will not happen in the data warehouse. So this is the data warehouse as a multi-tier architecture. Okay, we have the operational database, we have external sources. So we call this as the data sources. We have the ETL. You still remember ETL? ETL is the extraction, or sometimes we call it extract. And then transformation, sometimes we call it as transform. And loading, or sometimes we call it as load. So E, T, and L. Okay, E, this one is from the extract, T is from the transform, and L is from load. Okay. After we do the ETL, so we will have the data storage, and based on the monitoring and based on the administration, there will be a metadata repository to handle the data warehouse. In the data warehouse, there will be a smaller data, we call it the data marts. And this kind of data storage will go to the OLAP engine, the online analytical processing, because we need to process the data before we make the report, before we make the query, before we do the analysis, before we do the data mining. Okay, this is the data warehouse environment. So this is the difference between the OLTP and the OLAP. In the OLTP, the user is clerk or front desk, IT professionals. But the OLAP, it is the knowledge worker. So you should have the data science background. You need to have the data mining background. The function of the OLTP is day-to-day operation, but the OLAP is more about the decision support. The DB design is more about application oriented. It's about sales or it's about the customer. But the OLAP is more about the subject oriented. The data is current, okay, because it is like 60 until 90 days, up to date, detailed, flat relational, isolated. But the OLAP is historical. Okay? We learn about the data is having a time horizon 5 until 10 years. So we can make summary, multidimensional, integrated, and consolidated. The usage is repetitive on the OLTP, but the OLAP, it is ad hoc. So when you need it, then you will extract or you can access it. The access of the OLTP is read, write, and change, delete. But the access on the OLAP, a lot of scans. So you just need to query and read. The unit of work is short, simple transaction, modify, read, or delete. But in OLAP, you need to have a complex query. Okay. And usually in the OLTP, the number of records that you want to access is maybe 10 or 20, not that many, but in the OLAP, there will be millions of records that you need to access. The users in OLTP, it might be only thousands, not that many, but it's more, okay, because you need to handle the daily. In the daily operation, usually there are so many things to handle, but in the OLAP, it is only hundreds because you need to handle only the simple problems. All data already stored in the database and there is no much issue to handle. The DB size is more about less than the OLAP because we want to focus only 60 until 90 days. Meanwhile, the OLAP, it is 5 until 10 years. So it is a huge data. The metric used in the OLTP is more about the transaction throughput. But in the OLAP, it is about the query throughput or the response. Why a separate data warehouse? Because when we are dealing with the analysis or decision support system, we need to have a high performance. And the OLTP also needs the high performance. If you combine the OLTP and the OLAP, then it will ruin the company. Okay. The OLTP needs access, method, indexing, concurrency control, and recovery. Meanwhile, the warehouse, you need to do complex OLAP queries. You need to have the multi-dimensional view and consolidation. So high performance should be available in OLTP, and high performance should be available also in OLAP. So it is a good way to separate data warehouse. And we have different function and different data. on OLTP and OLAP in the handling of missing data. So if you are dealing with the data warehouse, we need to do something with the missing data, but you don't need to modify the operational DB. Okay, you can do with, for example, I want to do the automatic handling of missing data. Okay, then I can do it without changing the data in the operational DB. Okay. The data consolidation, it means the decision support requires consolidation, aggregation, summarization of data from heterogeneous sources, and data quality. Different sources typically use inconsistent data representation, codes and formats which have to be reconciled. So note, there are more and more systems which perform OLAP analysis directly from relational database. Yeah, if you have a good main computers, you can perform the OLAP directly in the relational database. But until now, it is a good practice to split between the OLTP or transactional database with the data warehouse. There are three data warehouses model. The first is the enterprise warehouse. The enterprise warehouse means a warehouse to collect all the information about subject spanning the entire organization. The entire organization means all departments in the organization. We have data mart. Data mart is a subset. You know, subset. Subset is a small set. Okay, it's a small set, or yeah, it's a partial of the set, okay, of corporate-wide data that is of value to a specific group of users. So its scope is confined to specific selected group. For example, we have marketing data mart. So marketing data mart, then yeah, it is a specific group for only the marketing department. Or we have sales data mart. Okay, so it is for sales department. Or we have the inventory data mart. Okay, we can say this is only for the inventory department, and so on. So data mart, it will be focused on specific users. We have the virtual warehouse. Virtual warehouse means a set of views over operational database. Only some of the possible summary views may be materialized. So you already know that the OLTP and OLAP, it is better, it is good if you split it. Okay. So OLTP and the OLAP, it is good if you split it. But sometimes the company, they need to extract from this OLTP, and we can create a virtual warehouse. So this virtual warehouse, usually we call it as view in the operational database. By creating this view, it is a temporary kind of temporary summary, and you can use it for your analysis. So the ETL, what we already learned from the figure before, it means we are going to extract, so get the data from multiple heterogeneous and external sources. We can do the data cleaning, means that detect the errors in the data and rectify them when possible. We want to transform, okay, data transformation. It means we want to convert data from legacy or host format to the warehouse format. So the host format means the transactional data, and we want to transform to the data warehouse. And load. So load means the requirement from the users. Maybe they want to sort the data, or they want to find the summary. They want to consolidate. So consolidate, what we learned before, it is about the aggregation, maybe about the summarization, and so on. Compute view, we want to find how many views that are available. Check the integrity. So we want to find whether the data is already integrated well or not. We can build indices. So some of the data should be indexed and partition. It means we want to split this on some requirement. Maybe we have 5 until 10 years data. Okay, let's do the partition by 1 year. So this is 1 year, 1 year, 1 year, 1 year, and 1 year, and so on. We can refresh. It means propagate the updates from the data sources to the warehouse. Okay. Let's do learning check. Mention 4 characteristics of data warehouse. We have the subject dependent, and then time variant, and then integrated and non-volatile. Okay, so you can check this one. Subject oriented, integrated, time variant, and non-volatile. What is the main difference between OLTP and OLAP? Okay, when you look at this main difference, I can just refer to this one. Okay. The main difference will be about the DB design, which is about the application for the OLTP, and this is about the subject oriented for the OLAP. And then the function is more about the day-to-day operation for OLTP, and OLAP is the decision support. And for about the data, it is a current data or up-to-date data, but OLAP is more about the historical data or summarized data. That's the main difference. You can explain with other characteristics. There are 3 data warehouse models. Can you mention them? Okay, so I already explained. We have enterprise warehouse, we have data mart, and we have virtual warehouse. Okay, so you can look at those terminology and explain the main tasks in ETL. What is ETL? Here we have extraction, transformation, and load. Okay, from the word extraction, transformation, and loading. So you can explain based on this one: extraction, transformation, and load. This one is the additional tasks in the ETL. Now we will look at the data cube and the OLAP in detail. From the database tables to the data cubes, as we already learned, the data warehouse is based on the multi-dimensional data model, which views data in the form of data cube. The data cube, such as sales, it allows data to be modeled and viewed in the multiple dimension. Okay, for example, in the dimension tables, we have item. The item table, it contains of item name, brand, type, or time. You can have the day, week, month, quarter, year. We can have fact table. It is about the measures. The measures such as the dollar sold and keys to each of the related dimension. In the data warehousing literatures, we have the ND base cube, or we call this a base cuboid. The topmost OD cuboid, sorry, this is 0, okay, 0D cuboid, which hold the highest level of summarization, is called the apex cuboid. The lattice of cuboids forms a data cube. Okay, let's see. Like this one. We have the right section, it is the data cube. Okay. This is the data cube. So how can we construct the data cube? Now let's see a daily transaction. TX1 is the transaction number 1. TX2 is the transaction number 2. Let's say the transaction number 1, Hung Gildong purchased LG TV 45-inch at Yongin Brands in 2020, January 4th, and paying Shipmanon, okay, 500,000 won. There's another person, Ilji Meh, purchased Samsung refrigerator 880 liter at Pundang Brands 2020 March 7, paying 1,250,000 back isi Manon. Okay. Now we have the customer table. Okay, this is in a database. You have the customer number, name, date of birth. Okay. DOB is date of birth. I think last time we already learned date of birth. Okay, and so on. For example, address. And then we have item table. The item table refers to the I01, which is Samsung refrigerator. Oh, the price is 1,450,000. Okay. The supplier is Samsung, and then you have I02 is the LG TV 45. The price is this one. The supplier is LG. The location L01 is Yongin Brands, location is Yongin. L2 is Pundang Brands, location is Pundang. Now you will look at the sales table. We combine. There is a transaction of T01. This is the T01, and the customer is C01. The customer is C01. But do we need to include all? No. We just need to input the key. So when we need the detailed information, we can go to the customer table and then get the detailed information. The item, okay, you can see that Hong Gildong purchased LG TV 45. This is the LG TV 45. This is item 02. And the Hong Gildong purchased it in the L01. L01, it is the Yongin Brands. And the date is 2020, January 4th. The amount that he paid is 500,000 won. The price is actually 600. Oh, why he paid 500,000 won? Okay, maybe there's a discount. Okay, there is an event. Okay, and then the transaction number 2. The transaction number 2. The customer is C02. Okay. And then the item that she bought is Samsung refrigerator. The location is in Pundang, L02, and the purchase date is 2020 March 7. And the amount price that she paid is 1,000,025. Okay, maybe there's a discount. So after we have this sales table, we can put this data into this cube. What is this cube? This cube includes the information about location. So this is the location. And then we include the item. This is the item, and include the time. Okay, the time means this is the date. So we can expand later the cube. Maybe you want to include also the customer. That's also possible. Okay. And each cells contain the sales amount of specific item at specific location during a specific time period. And each dimension may have a hierarchy. So day, it is higher than month, is higher than quarter, and it is higher than year. Okay. I mean, higher is the hierarchy. Okay. So day is very detailed, month is less detailed, quarter is lesser detail, and year is the very least detail. Because in 2020 there will be a lot of months and there will be a lot of days. Okay. So we call this is a cube. Okay, a cube or a lattice of cuboid. We call this is a cube because there might be a possibilities how to combine the attributes. For example, if I want to use the 0D, 0D means 0 dimension, then yeah, I don't have any things, I just combine all the data. But if I want to have one-dimensional cuboid, so I can use one attribute, which is time, item, location, and supplier. If I have two dimension, okay, so it is two dimension, then I have time and item, time and location, time and supplier, time and location. Maybe this is item and location. Okay, so and then this is item and supplier, location and supplier. Okay. And we can combine into three. Okay, so three dimension. It is a combination between those attributes. So time, item, location, time, item, supplier, time, location, supplier, and item, location, supplier. This is what we call a space cuboid or 4D because we have 4 dimension. Okay, 4 dimension, it is the 4 attributes: time, item, location, and supplier. So in the conceptual modeling of data warehouse, we have the dimension and measures. And there are 3 kinds of conceptual modeling in the data warehouse. The first is the star schema, next is snowflake schema, and last is fact constellations. The star schema is a fact table in the middle connected to a set of dimensional tables. The snowflake schema is a refinement of star schema. Okay, a refinement. It means we have the star schema. The star schema is this one, but it is refined, or yeah, we can say it is normalized. Yeah. So some dimensional hierarchy is normalized into a set of smaller dimension tables. It forms a shape similar to snowflake. Because you know snowflake is like the moon. Okay, yeah. And we have fact constellation. There might be multiple fact tables, share dimension tables. It is viewed as a collection of stars, okay, a collection of stars, therefore called galaxy scheme or fact constellation. Maybe it's better to see the figure like this one. Because this is a star scheme. The fact table is in the middle, and then we have dimension tables, dimension tables, dimension tables, dimension tables, dimension tables. So you can see this is a sales fact table, a fact table, and then you want to consider only the time key, item key, branch key, location key. Okay. And the dimension tables contain the time, contain the item, contain the brands, contain the location. And now it includes some of the measures. The measures are about the unit sold, so how many items that has been sold, and the dollar sold, so how many dollars that the stores got, and maybe some other measures like the average price. If it is a snowflake schema, so we have a fact table in the middle, and we have dimension table to indicate the detail of this fact table, and there will be another sub-dimensional table. Okay, there will be another sub-dimensional table. This sub-dimensional table means the detail. For example, I have this fact table, and this item key correlate with the item, and the item has more data about the supplier key. So the supplier key connect to another dimensional table. We call it the supplier. Or the location, we have the city key, and it connects to another dimensional table, which is the city. So we call this is a snowflake schema. So one attribute in the dimensional table can connect to another dimension. About the fact constellation, in the fact constellation, so we can connect the fact table and connect to another fact table. So the fact table, usually we have only one, but there might be more or multiple fact tables. So we have sales fact table, it is connected with the shipping fact table, and all those dimensional table are correlated. So in the sales fact table, they have time. The shipping also have time. The sales fact table, we have item, and the shipping, we have also item. In the sales fact table, we have the brands. The shipping, we connect with the shipper. In the sales, we have location, so where the person bought the items, but the shipping, it contains from to location. Okay. So some of the dimensions are similar, meanwhile other dimensions might be different. So the shipping fact table connect with the shipper, but the sales fact table connect with the brands. The measures is also different. When the measures in the sales is only about how many items that has been sold and how many dollars that had been obtained, but in the shipping fact table, it is more about the cost delivery, the delivery cost, and how many items has been shipped. So the concept hierarchy, okay. The concept hierarchy is like this one. When you have the location, you can have all region, and then maybe the continent, the region, Europe or North America, and then you can mention the country, Germany, Spain, Canada, Mexico, and then you can mention the city, maybe the Frankfurt, okay, the Canada, Vancouver, Toronto, and the office. For example, who is in charge in the Vancouver? Maybe this is the office in one city, in one branch of Vancouver. It is the second branch. This is the person who are in charge in the city and in the office, and etc. The data cube, okay, we have measures. Okay. What are measures? Okay, so this is measures. How many items has been sold, how many dollars that has been achieved, and then what about the average sales. So these measures, we can also put it into the data cube. So in the data cube measures, we have three categories. The data cube measures is distributive, algebraic, and holistics. So if the result derived by applying the function to n aggregate values is the same as derived by applying the function of all data without partitioning, okay, then it is distributive. For example, like this, this is a function, yeah, to aggregate values, yeah, without partition. Without partition means like this. I just want to calculate how many. We have row 1, row 2, row 3, row 4, column 1, column 2, column 3. So I want to know how many items in the row. Okay, we have 3. And what is the minimum? Okay, 1. What is the maximum? Okay, it's 3. So that's the distributive. With regard to the algebraic, if it can be computed by algebraic function with m argument, where m is bounded integer, each of which is obtained by applying a distributive aggregate function. For example, I want to know the average of this one. Okay, this is an algebraic function. Okay. Well, maybe I want to know the standard deviation. Okay. The holistic, if there is no constant found on the storage size needed to describe a sub-aggregated. So some other function, for example, median. Yeah, median is you need to sort the data and then you need to find the middle value. Okay. Or mode, so it means the most frequent values, or rank, based on particular standards, maybe based on the frequency, you can rank numbers. This is a view of data warehouse. So if you have this kind of data warehouse, you need to specify the hierarchies. Yeah, for example, the dimension is product, region, revenue, cost, profit, order quantity, and you have measurements. And this is the cubes. So if you have the sales data cube, then okay. And the level name, it can be seen like this one. If it is based on the region or the country or the branch name or the republic name. Sorry, representative name. Okay, this is the office. So you can look at this one in the Europe. Okay, there are Belgium, France, Germany, Spain, Sweden, United Kingdom. And in the North America, we have the Canada, and some office in the Canada is Montreal, Toronto, Vancouver. Okay, those are the leaders or the representative in the office on the Vancouver city. And if you are dealing with the multi-dimensional data, of course, you already learned from the previous section about the data pre-processing. Okay? We can distinguish the level, or we can do the roll up, or we can aggregate and etc. Okay? So it is about the sales volume as a function of product, month, and region. Product, month, and region. So we have the dimensions, product, location, time. And for the hierarchical, we can make the summary. For example, I want to know the product, and then I want to know the category and what is the industry. Or if you want to deal with the region can be summarized with the hierarchy, country, city, and office. For the time, we can have the year and then decrease to quarter and then go to month, or from the year, we want to check the week, and finally, we want to look at the day. So it is a sample of data cube. Okay. In data cube, we have the product and date and the country. So this data represent the data from USA in the first quarter, and the product is TV. This data refers to the product from USA in the fourth quarter, and the product is TV. So we can do the summation. This is the summation of total annual sales of TV in USA. This is the annual sales. This is the sales in the Q1 of all product, and so on. So if you look at this one, then it means you want to sum for all the data. Cuboids corresponding to the cube. If you already know the cube that might be possible for the construction, then you can start from the 0D. And then what is the 1D? Okay, we have the product, date, and country. And then the two-dimensional, we can combine, for example, product and date, product and country, and date and country. And we have the product, date, and country as the 3-dimension. This is the typical OLAP operation, okay? Like the roll up, drill down, slice dice, pivot, and other operation. We call it roll up or drill up. It is to summarize the data. So by climbing up hierarchy or by dimension reduction. We call drill down or roll down is reverse of the roll up. Reverse. Reverse means bande. Okay. From higher level summary to lower level summary or detailed data or introducing new dimension. We have the slice dice is project and select. We have a pivot or rotate. It means we reorient the cube. We can do visualization, 3D series to 2D plane, and some other operation. For example, drill across. It means we want to invoke more than one fact table and drill through. We want to go through the bottom level of the cube to its back-end relational tables. So this is an example to show. Okay. The drill up, drill down. What is drill up? In the drill up means you can see this is a city, Florence, Venice, Nice, Lyon. So we want to drill up on location from cities to countries. So these cities will be drilled up to countries. What about drill down? Drill down, let's say this is an example, drill down on time. Okay. So we have winter, spring, summer, fall, and we want to drill down into month. So we have January, February, March, April, May, June, and so on. Slice and dice. We call it slice. Let's say I have this data cube, okay, and I want to slice the data for time equals to winter. Then only this section will be cut and we will look at the details. Only on winters, on every products, it means the clothing, bikes, and accessories, and for all the cities. Dice. Dice means we want to dice based on a particular condition. For example, this one, dice for location equal to Venice or Florence, and season equals to winter or spring. Okay. And items equals to components or clothing. So you can have dice or the result from this constraint. Pivot. Pivot means we want to we want to change the structure. Okay, let's say I have the location. Okay, so Chicago, New York, Toronto, Vancouver, and then I have the mobile modem phone security. And once I pivot it, So it is transformed. This city is here and this item is here. So the number 605 will be here, the number 825 will be here, the number 14 will be here, and the number 400 will be here. Okay, so this is a pivoting bit for the cities and items. There's another process or procedure in the data cube. We call it drill across and drill through. For drill across, you can see, for example, the product 1 is 40, the product 2 is 52. So I want to know each of the detail. So product 1, client 1, product 1, client 2. So it means I want to across from some more details information. This one product 2 of client 1 and product 2 of client 2. If it is about the drill through, okay, the drill through means I have the revenue from the region. Let's say this is America, Asia Pacific, Central Europe, and so on. And I want to drill through this one into the product line. It means from this data, I can see that camping equipment has a revenue this amount, golf equipment has the revenue this amount, mountaineering equipment has revenue of this amount, and etc. So we call this is the drill through summary report to a detailed report showing revenue break up by product line. There's more a complicated model. We call it the StarNet query model. Okay, the StarNet query model, it refers to more details information like what is the customer orders, what is the customer, what is the product, what is the organization, what is the promotion, location, and what is the time, including the shipping method. So in the StarNet query model, let's say the customer order is based on a contract. Okay, I don't put the customer information, and then I know that I want to access the product group on specific district in a particular countries, which is based on the quarter or quarterly. Yeah. Then you can get the data based on this kind of model. So you can look at this dot. This dot represent that the data is available on that particular category. For example, the shipping method is air express or the shipping method is truck. This one, the product is either product item or the product line or product group. In the organization, we can look at the salesperson or the district or the division, and etc. We can browse the data cube by using visualization with some OLAP capabilities and interactive manipulation. So if you look at this visualization, yeah, you can look at the location, the product, and the revenue. And okay, this is a huge. Okay, so the product here is the outdoor product, and in the North America, right? And okay, the revenue is between 0 until 200, 2000 US. Okay, there are a lot of transactions on this one. Okay, so how many dimensions are there in data warehouse? Okay, how many dimensions we have? How many dimensions? Yeah, you can see, yeah, in the data, in the dimension we have two, which is the two-dimensional table and the fact table. Okay. So this is the dimension. We have dimensional tables and the fact table, and the dimension tables can be in the sub-dimensional table. Okay. How many measures are there in data warehouse? Mention it. In the data warehouse, we have three kind of measures: distributive, algebraic, and holistics. Okay. And you mentioned the typical OLAP operations. This is the typical OLAP operations. We can have roll up or drill up, drill down or roll down, slice and dice, pivot, and we have drill across, we have drill through. Okay, so this is the typical operation in OLAP. Okay, I will stop this video here and I will continue with other video.